Hello folks, we come to the part 5 video of this exercise 1.1 and let's continue with what we had we were doing in the previous part. Here they give us an example of a set R with all ordered pairs A and B such that A is less than or equal to B. In such a situation, they say that this relation is reflexive and transitive, but it's not symmetric. So automatically reflexivity and transitivity, we kind of show it, prove it, and symmetricness, we will probably give a counter example as to why it doesn't happen. So let's start right away. Let's start with the reflexivity. Let's consider some AA or XX, whatever. Consider some AA. Yeah. Now, whenever you take an element AA, where A is a real number, if you want, you can specify A is a real number because that's how they have specified our relation R. Any real number is always less than itself, less than or equal to, because that equal to thing is there. There's absolutely no harm. If that is the case, that's condition enough to show that it belongs to R, isn't it? So that's how it belongs to R. Now once you have these kind of elements belonging to R, so this is any general, so you take any element, this will happen, right? You take any real number, as I said in the before problem, root 2, maybe 5 by 6 or 7 by 9 or whatever, you take any element, this will happen. So as a result, this will always belong to R. That is what is making R as reflexive. So R is reflexive. We are done. Then we'll talk of symmetricness, right? And in symmetricness, it is told to us that it's not symmetric. So we only need to give a counter example. Let's take where it is going to work. Let's take some 1, 2. Whether it belongs to R? Yes, because since 1 is less than or equal to 2, right? So it will belong to R. But we consider 2, 1. What happens? Whether 2 is less than or equal to 1? No. 2 is not less than or equal to 1. And as a result, 2, 1 doesn't belong to R. So starting with this 1, 2 which is belonging to R, we are getting this 2, 1. It's not belonging to R. As a result, R is not symmetric. Right? That's how R is not, we get R is not symmetric, and that's a counter example. Now we check the transitivity. So transitivity also, they have told, it's hinted to us that it is it is transitive. So we have to kind of give a short proof. So let A, B and B, C belonging to R. Now see, it's a big set. This relation R, if you try to actually list it, you'll not be able to list, because it is consisting of so many real numbers. Like we could have 1, 1, 1, 2, 1, 3, 1, 4, 1, 1000, 1, 10,000, 1, whatever. So many elements with 1 itself. Then you take 2, you'll get so many elements. So it's impossible to list it. So listing method of solving this cannot be done. That is why we have to go for generalizations. So you have this AB and BC belonging to R. So what happens? AB and BC belongs to R. Therefore, if it has to belong to R, it has to satisfy the condition. So it's like A less than or equal to B, B less than or equal to C, right? Because it is belonging to R, it will satisfy these two properties. Now you just watch this close. A less than or equal to B, B less than or equal to C. What will be the relation between A and C? A will be definitely less than or equal to C. No, we always have 3 less than or equal to 5, 5 less than or equal to 7. Automatically 3 is less than or equal to 7, right? I mean, that's how it is. So same thing will happen here. Therefore, A is less than or equal to C, and that will mean that A, C belongs to R. So look over here, starting with AB and BC belonging to R, you have got AC belonging to R. Therefore, R is transitive. R is transitive, right? I don't know whether they've asked is no, you cannot, because symmetricness is not there. Sometimes when all the 3 are obeyed, they sometimes ask us to show equivalence relation. That is when all the 3 are obeyed. Here symmetricness is not obeyed, so you cannot have an equivalence relation. quickly we jump to the next question, which says that R is the relation R is set of all the AB such that A is less than or equal to B cube is reflexive, symmetric or transitive. You have to check. They have not specified anything, and my intuition says that neither will be true. So actually we should be hunting for counter examples for all the three. Yeah, that's what my intuition says. Let's check. So first we will check for reflexivity. I've told you in 9 out of 10 cases the fraction logic will work fine. Okay, so let's take that earlier case we had taken a fraction half comma half. Let's take that and let's see how it is working. So consider half comma half. Here half, we will always check this condition. Whether half is less than or equal to 1 by 8? No, because half is 0.5 and 1 by 8 is 0.125. Doesn't happen. So it is not less than. When it is not less than, it cannot belong to R, right? Only if you satisfy that condition, you can that particular element can belong to R. Now, because this half is not satisfying the condition, it cannot belong to R. Therefore, half comma half cannot belong to R, right? Therefore, R is not reflexive. Moment you have found one element, see, for satisfying, it should be satisfied, the particular property should be satisfied for each and every element. If you are able to find even one element where there is a discrepancy, then that relation will no longer be, like, it will not obey whatever property that it is supposed to. So, reflexivity is not there. Now, we will check for symmetricness. Yeah, let's check. Our famous 1, 2. Let's check if it is working fine here. 1, 2, whether it will belong. It will belong. So let's check. Let 1, 2 belong to R. Since why 1, 2 is belonging? Because 1 is less than or equal to 8, which is 2 cube. Right? That's why it is belonging. But now see, we're just trying. If it is not working, we'll quickly alter and find out some other example. But you consider 2, 1 is such that 2 is less than or equal to 1 cube, which is 1. Is it true? Never. So this doesn't happen. As a result, 2, 1 doesn't belong to R. So we start with 1, 2 belonging to R, but we reach at 2, 1 which is not belonging to R. As a result, R is not symmetric. See, technically, you are supposed to write this, one more step, fresh step. Thus, 1, 2 belonging to R implies that 2, 1 doesn't belong to R, and therefore R is not symmetric. That step has to be there actually. But every time when we are going to write that in all the three, it becomes a little voluminous. Your steps, it involves a lot of writing. That is why we are showing these arrows, and you have to, check for yourself, which is going to be, you shouldn't be losing marks. So accordingly, you should frame your thing. It's advisable to write this and then write this so that your step is complete. Then we have this transitivity. Right. Now transitivity again is not going to be true. So we have to check for examples. It has to come like this. So variant. Belonging to R, we'll check. If it is not belonging to R, 80 can become 40, 6 can become 9 or whatever. We can alter it accordingly. Let's check this. Since 80 is less than or equal to 6 cube. What is 6 cube? 6 6 are 36. 36 into 6, 216. It is. Right, that's how it is belonging. Look over here. 6 is less than or equal to 3 cube. What is that? 3 3s are 9, 9 3s are 27. Yes, both these conditions are satisfied. That is why they are belonging to R. Okay, but let's check 80, 3. Whether if it is belonging, then we have to change the thing, but otherwise it will work. is such that 80 and 3 cube, which is 27, is not less than or equal to 80 is not less than or equal to 27, right? As a result, 80 comma 3 cannot belong to R, right? It's not belonging to R. So starting with this particular element which is belonging to R, you are having this element which is not belonging to R. As I said, no earlier case, you have to have steps like this. Thus 80 comma 6, 6 comma 3 belonging to R implies has 80 comma 3 not belonging to R. Therefore R is not transitive. It's not transitive. So all the three things are not getting obeyed here. That's what we wanted to tell. That's all about this part of the video where we have covered these two questions. More problems in the next video. Thank you.